Okay, so this is section 6.1, which is matrix solutions to systems. Okay, the first thing we are going to talk about is how to rewrite a system of equations as an augmented matrix. Okay, so for example, if we have the system of equations that is this system, 3x plus y plus 2z equals 31, x plus y plus 2z equals 19, and x plus 3y plus 2z equals 25. Okay, so that is our problem. We want to turn that into an augmented matrix. An augmented matrix is essentially a matrix that includes all the numbers from the whole problem, and it's what we use to solve the system. The augmented matrix is going to have all your coefficients in front of your letters just like before. So it's going to have 3, 1, 2 on the first row, 1, 1, 2 on the second row, 1, 3, 2 on the third row. And then it's going to have a line, and then we're going to have our solutions over here, the answer, not solutions, but the other side of the equation. So 31, 19, and 25. And that's your augmented matrix. Okay, let's do one more like that. If I had the system x plus 2y minus 5z equals negative 19, y plus 3z equals 9, and z equals 4. Whenever I put this into an augmented matrix, that first row has 1, 2, negative 5, draw your line, and then it's negative 19. For the second row, what's the number in front of x here? 0. So 0, a 1 for the y, a 3 for the z, and 9. For the third row, what's the coefficient for x? 0. What's the coefficient for y? 0. Z is 1, 4. Okay, this is really special. This is called row echelon form. All these funny names today. Okay, so this specifically is called row echelon form. Let me verify I spelled that right before we write that down. ECHELON, yes. Okay, what is special about this is notice the diagonal right here. What numbers are on the diagonal right here? X, Y, Z. Yeah, what's your coefficients here? They're all 1, right? Look at the numbers below my diagonal. What numbers do I have below my diagonal? Zeros, and then I just have regular numbers above it. This is really, really important because at this point, we can solve this equation. If I know z is 4, can't I plug in 4 right here to find y? And then whatever I get for y, can't I plug that in here for y and the 4 for z to find x? So if I can get it into row echelon form, I can just back substitute and solve the whole thing. So that's our goal today, is row echelon form. a diagonal of ones, zeros under your diagonal, and then just, it doesn't matter what the numbers are above it. Okay. So the way I get things there is by doing matrix row operations. Okay, so we can write this out, but I think that I have it already written out and it does a little bit better job. So if you look at this on the last sheet of your note sheets, we can do three things to our matrices. Okay, we can interchange the elements on the, it says ith row and jth row. So basically on any two rows, and we switch those by saying like for example, if we did row 1 and row 2 and we want to switch row 1 and row 2, you would put R1 like that and R2 right there, and you just switch everything on the two rows. Okay, so for example, let me show you an example of that. We're going to do a lot of these because if you can't do this part, you can't move on to the next part. So for example, let's pick this, our first example up here, not the row echelon form, this top one. Let's take that equation, this augmented matrix. So this is our example we're going to work with. So 3, 1, 2, 31, 1, 1, 2, 19, 1, 3, 2, 25. And let's switch row 1 and row 2. When you switch row 1 and row 2, you literally flip-flop the rows. So row 2 is going to go in place of row 1 now. 1, 1, 2, 19. 3, 1, 2, 31. 1, 3, 2, 25. Okay, so all we did here was switch row 1 and row 2. Questions about that? Pretty straightforward. The next one, you can multiply each element in a specific row by a number k. It can be any number. It can be 5. It can be -2. It can be a half. It just depends on the situation here. So, for example, if I have that original matrix, 3, 1, 2, 31, 1, 1, 2, 19, 1, 3, 2, 25. This time I'm going to do, let's do -2 times row 2. So all that means is I'm going to multiply everything in row 2 by -2. So row 1 stays the same. 3, 1, 2, 31. Row 2 is now -2, -2. 2 times -2 is -4. 19 times -2 is -38. And then row 3 stays the same. 1, 3, 2, 25. Everybody good with that? Okay, the last one's the hardest because it's a couple steps altogether. Okay, so we can add k times the elements in row I to the corresponding elements in row J by doing this, k times row I plus row J. So what that means is, I'm gonna turn it over. Let me write my, what is it? 3, 1, 2, 31, 1, 1, 2, 19, and 1, 3, 2, 25. Okay, so I'm just going to show you an example, and then after you kind of get the idea of it, then I'll tell you like the purpose of all this. So let's do -1 times row 1 plus row 2. So what this says, this is like kind of confusing because it seems like you would do a lot of different things here. But what this says is row 1 stays exactly the same. Okay. Row 1 stays the same. Row 3 also stays the same. So row 1 and row 3 are exactly the same. The last thing right here that you're adding it to, that's what changes. Row 2 changes. And what we do to row 2 is we do -1 times row 1 plus row 2 and write it in place of row 2. Okay, so we are replacing row 2 with -1 times row 1 plus row 2. So row 1 stays exactly the same. I just use it to figure out my new row 2. Okay, so what we could do is you could go ahead and write row 1 and row 3 first. 3, 1, 2, 31. They stay exactly the same. 1, 3, 2, 25 stays exactly the same. As you do this, you're going to be doing it in your head, but I'm going to go ahead and write it down on paper first. Let's go ahead and multiply row 1 times -1. So 3 times -1 is -3. 1 times -1 is -1. 2 times -1 is -2. 31 times -1 is -31. And then I want to add row 1 and row 2 together. So what is -3 plus 1? -2. What is -1 plus 1? 0. What is -2 plus 2? 0. And what's -31 and 19? 12? -12? Yeah, -12. Does that make sense how to do that? Okay. So let's do a couple more like that one, and then we will move in to the whole purpose of doing this. I don't think anybody has any trouble. Well, and usually, let me know if you do, because we can definitely spend time on it. But usually nobody has trouble switching rows. Nobody has trouble multiplying a row by a number. It's this one that people have a hard time with. So let's do a couple of those. Okay. So our new problem we're going to work with is the matrix 3, 18, -12, 21, 1, 2, -3, 5, -2, -3, 4, and -6. I'll take it back. On the first one, let's go ahead and do 1/3 times row 1. So we didn't do a fraction last time. Multiplying row 1 by 1/3 is the same thing as dividing by what? Dividing by 3. Okay. So our new answer, like our new matrix here, if I divided row 3, I'm sorry, if I divided one row, if I divided row 1 by 3, I would get 3 divided by 3 is 1. 18 divided by 3 is 6. -12 divided by 3 is -4. And 21 divided by 3 is 7. Everything else stays exactly the same. That's still positive, huh? -2, -3, 4, -6. Okay, let's take that initial equation, not the new one we just wrote, the example problem, I guess. And let's do 2 times row 2 plus row 3 this time. Which row am I writing my answer in? in row 3. Row 1 and row 2 stay exactly the same. So you could go ahead and write row 1 and row 2. 3, 18, negative 12, 21. Row 2 stays exactly the same. 1, 2, negative 3, 5. Row 3 is what changes. So to figure out the answer that goes in row 3, I'm going to multiply row 2 times 2 and add it with row 3. So what is 1 times 2? 2. What's 2 plus negative 2? 0. So that's the number that goes in the first spot. Go to the second part in row 2. 2 times 2? 4. 4 plus negative 3 is a 1. Negative 3 times 2? Negative 6. Negative 6 plus 4? Negative 2. 5 times 2 is 10. 10 minus 6 is 4. Does that make sense how to get that bottom row? Okay, we're going to do one more of those, but notice kind of the purpose of this. On this one and on the one before, I didn't have any zeros starting off, but I got a 0 by doing that. Okay, so the whole purpose of doing that part right there, multiplying a row by something and adding it to another row, that's what's going to get us our zeros down here in our row echelon form. Okay, look at the first one. 1/3 dividing by 3. That turned that 3 into a 1. Okay, so that's what we're going to do to get our 1s down the diagonals. Okay, it's either that or notice on this first one, I had a 3 in that first spot. I switched rows to turn it into a 1. Okay, so you're either going to switch rows or multiply by something to get your 1s. You're going to do this process to get your 0s. And the order that we're doing this matters, and we'll go over that in just a minute. Let's do one more of these just to practice it one more time, and then we will move on. Okay, so that same that same matrix, the 3, 18, negative 12, 21. Let's take that matrix and let's do sorry, let me think for a second. Row 1 plus 6 times row 3. Which row are you replacing and writing your answer here? Row 3. It's always the last number, the last one right there. It doesn't matter which one you multiply. It's this one right here that you're always replacing. Okay, so keep row 1 and row 2 the same. Replace row 3 with row 1 plus 6 times row 3. Let's take a second to do that. Okay, so for that one, it would be 3 plus 6 times negative 2. 6 times negative 2 is negative 12. Negative 12 plus 3 is negative 9. 18 plus 6 times negative 3. 6 times negative 3 is negative 18. 18 plus negative 18 is 0. Negative 12 plus 6 times 4. 6 times 4 is 24. 24 minus 12 is positive 12. And 21 plus 6 times negative 6. 6 times negative 6 is negative 36. Negative 36 and 21 is negative 15. Is that what you got? Okay. So the reason why we're doing all this multiplying rows, adding rows, so on and so forth is because, again, we want to get to row echelon form. And row echelon form is where you have ones down your diagonals, zeros underneath the diagonal. Oh, that's kind of the wrong spot. It should be right there. And then all the rest is numbers. So I'm just going to put A, B, it's written like this, C, D, E, F. It doesn't matter what the numbers are. Okay. The most important thing is to have ones down the diagonal like this and to have all zeros underneath your diagonal. If you have ones down the diagonal and you have all zeros underneath, you basically have it solved. You just need to back substitute to get all the answers there. Okay, so this process of getting it to row echelon form by multiplying a row by something, or by switching the rows, or by adding the rows together, like multiplying and adding the rows together, this is called Gaussian elimination. And again, if you'll pull out your notes do a great job of showing the process instead of having to write it all out. If you look at the bottom here, it says solving a system using Gaussian elimination. Your goal here, this is like the process. First thing you want to do is get that one on top right there. Top left-hand corner, you want to make them 1. After you get the 1, you want to get zeros underneath it. Okay, you can't, if you go in the wrong order, if you try to get the zeros first and then the 1, it messes up your zeros later on. Okay, so you want the 1 first and then the zeros, and then it'll stay 1, 0, 0. After you get that first column done as 1, 0, 0, you move on to the next one. I don't care what's on the top here, it's just a regular number. I need a 1 in the second part here. Okay, so you get the 1 there. After you get the 1 there, then you get the zeros underneath it, which in this case, there's just 1 0 underneath it. And then you get that last 1. Okay, so that's your goal every time. We are going to do a problem. We're going to start off with a 2 by 2 matrix. So for row echelon for a 2 by 2 matrix is same idea. It just is going to be a 1 here, a 1 here, because you only have 2 equations. A 0 underneath your ones. There's only one place for a 0, a number, a number, a number. Does that make sense? The pattern's the same no matter how many equations, how many variables you have. So you want your 1 on your diagonals. You want your 0 underneath, and all the others are just regular old numbers. Okay, so let's start off with the 2 by 2. Let me find a 2 by 2 matrix real fast, and we will practice with that before we move on to a 3 by 3. Okay, so if I had the equation or the system x plus y equals 1 and x minus y equals 3. If you were actually going to work this system out, I would not use Gaussian elimination for this because this one is set up to do elimination so easy and so quick, right? But we're just going to go ahead and practice it. Okay, so let's put it as an augmented matrix first. So the coefficients here are 1, 1, put your line, and 1. And 1, negative 1, and 3. Okay, our first goal is to get a 1 on the top left-hand corner. Do I have a 1 there? Check. If you did not have a 1, you could switch rows to make a 1. Or if this was like 3, 3, 3, you could divide everything by 3. Does that make sense? Okay, we will have some examples like that in a minute. So check, I got a 1 there. It's going to stay there for the rest of the problem. Now I need to get the zeros underneath the 1. Do I have a 0 underneath the 1? The way you get zeros is by doing like, 2 times row 2 plus row 1 or whatever the situation is. In this case, I need to make 1 go away. Okay, I need to make this turn into a 0. What do I need to add to 1 to get a 0? A -1. I need to do 1 plus -1, right? How am I going to get a -1? I have to use row 1. And what do I need to multiply it by? -1. So what I need to do is -1 row 1 plus row 2. Does that make sense why I'm doing that? I'm trying to get a 0 here. So I need to add a -1 to that. The way I add a -1 is by doing -1 times the top row and add it to the bottom row. So I get, top row stays the same, 1, 1, 1. The bottom row is top row times -1 plus bottom row. -1 times 1 is -1. -1 plus 1 is 0. For the second part, -1 times 1 is -1. -1 plus -1 is -2. -1 times 1 is -1. -1 plus 3 is 2. Okay, so I have my 1 in the top left-hand corner. I have all the zeros underneath it. I only needed 1 in this case. Okay. What's my next step? You got to get your 1 on, you got to move on to the next column. You got to get your 1 on your diagonal. Which one's the 1 on the diagonal? The -2. I need to turn this into 1. The way you turn numbers into 1 is by switching rows. Don't do that at this point. Okay. Only switch rows to get a 1 in the first spot your first time. Because what would happen if I switched rows right here? It'd mess up everything we just did. Okay. So don't switch rows to try to get a 1 here. Instead, I'm going to multiply this or divide this by something to turn it into 1. What do I need to multiply by to turn it into 1? -1/2. Right, to get +1. So I'm going to multiply this by -1/2 times row 2. I'm fine if you also want to think about that or like write it as like row 2 divided by -2. I'm good with that too. But just a heads up, any help you're going to get on Math Excel, it's going to put it like that. Okay, so top row 1 stays exactly the same. 1, 1, 1. Row 2, I'm going to divide by -2. 0 divided by -2 is 0. -2 divided by -2 is a 1. 2 divided by -2 is -1.
Is my mom
I have succeeded at this point. Okay, I have this in
not in the house?
row echelon form. I have 1s down the diagonal. I have a 0 underneath my diagonal. So that means I can solve this easily. Okay, the way you solve it is you put it back into letters. The top equation is x plus y equals 1. What does the bottom equation say?
I mean, he's hunched over.
Okay, then yeah.
Y equals -1. So I know what y equals. How do I find x? Substitute it back in the top equation. When I'm kind of running out of room here. When I substitute it back in the top equation, I get x plus -1 equals 1. Subtract 1 from both sides, and I get x equals 2. And so my answer is 2, -1.
Like, I don't know what she's doing with my grandpa.
That is not at all the fastest way to do that specific problem. Okay. But it was an easier version of the 3-step problems that we're going to be doing. Ideally, I have another 2 by 2. I don't think we have time to do it. Let me just show it to you. Okay, so if this was the equation, x plus 2y equals 2, -4x plus 3y equals 25. My augmented matrix is 1, 2, 2, -4, 3, 25. Do I have a 1 in the top column or top spot? Yes. My next step is to get a 0 underneath. How am I going to get a 0 right there on the bottom? What would you multiply and what would you add? I need to multiply this top row by 4 and add it to the bottom row. So that's 4 times row 1 plus row 2. When I do that, top row stays the same. This is 4 times 1 is 4. 4 plus -4 is 0. 4 times 2 is 8. 8 plus 3 is 11. 4 times 2 is 8. 8 plus 25 is 33, right? So now I have 1, 0. I need to get a 1 right here. The way to turn 11 to a 1 is divide by 11. So I divided by 11. That bottom row becomes 0, 1, 3. So then from here, I write my equations. X plus 2y equals 2, y equals 3. Plug in 3 for y, solve for x, get -4. Does that make sense? Okay, let's move on to a 3 by 3 problem. Okay, so our system is 3x plus y plus 2z equals 31. X plus y plus 2z equals 19. X plus 3y plus 2z equals 25. Sorry, yes. Okay, first thing, make it an augmented matrix. So my augmented matrix turns into 3, 1, 2, 31, 1, 1, 2, 19, 1, 3, 2, 25. Our first step is to get a 1 in the top left-hand corner. Do I have a 1 there now? No. Technically, you could divide that top equation by 3. Would that be pretty? No, it wouldn't. What would be much easier to get a 1 in the top left-hand corner? Switch 2 rows. Yeah, I'm going to switch row 1 and row 2. You could do 1 and 3 if you wanted to. It doesn't matter. Just pick one of them that has a 1 in the first spot and switch rows. Okay, so I'm going to switch row 1 and row 2. So I get 1, 1, 2, 19, 3, 1, 2, 31, 1, 3, 2, 25. Okay, I have my 1 in the correct spot, right? What am I trying to fix now? I need to fix this 3 and this 1. They both need to turn into zeros, right? Because you need to have zeros underneath your 1. You can, which as you get a little more comfortable with these problems, you can do this in one step. Okay, because I need to turn the 3 into 0 and turn the 1 into 0. If I'm going to turn the 3 into 0, I need to add -3 to that. How am I going to get a -3? -3 times R1, right? So I need to do -3 times R1 plus R2, and that fixes that 3. Okay, so right now I could go ahead and write my answer and then go ahead and do the 1 underneath it, or you could actually do both of these at the same time. Okay, and that's what I'm gonna go ahead and do. You don't have to if you don't want to, it just saves paper. So on the last one, to fix row 3, that 1 needs to turn into a 0. How am I gonna turn that 1 into a 0? Multiply top row, -1 times row 1, and add it to row 3. Do you kind of see the benefit of getting a 1 here first? Because then you can just multiply it by anything to fix any number underneath it. Okay, so row 1 stays the same. It's still 1, 1, 2, and 19. For row 2, I want to multiply the top row by -3 and add it to the second row. So 1 times -3 is -3. -3 plus 3 is 0. 1 times -3 is -3. -3 plus 1 is -2. 2 times -3 is -6. -6 plus 2 is -4. And the hardest part, -3 times 19 is 57. Is that right? 19 times 3. -57. -57 plus 31 is 26. -57 plus 31 is -26. Everybody good with that? Okay, let's go ahead and do the third row now. I want to do -1 times row 1 plus row 3. So -1 times 1 is -1. -1 plus 1 is 0. -1 times 1 is -1. -1 plus 3 is 2. -2 times 1 is -2. -2 plus 2 is 0. -19 times, I'm sorry, -1 times 19 is -19. -19 plus 25 is 6. -19 plus 25, yeah. Okay, I got a 1 on top. I got zeros underneath. Column 1 is finished. What do I do next? I need to turn this into a 1 now. At this point, you cannot switch any rows because you're going to mess up that column 1 that's already finished. So at this point, the way you turn that into a 1 is you divide by something. What am I going to divide by here? Multiply by -1/2 or divide by -2, either way. Okay, so I'm going to do -1/2 times row 2 now. Row 1 stays the same. 1, 1, 2, 19. Row 2, 0 times -1/2 is 0. -2 times -1/2 is 1. -4 divided by -2 is +2. -26 divided by -2 is +13. And then row 3 stays the same, 0, 2, 0, 6. Let's see where we're at. Column 1 is still good, 1, 0, 0. Column 2, I needed a 1 in row 2. What do I need underneath that 1? A 0. I need to turn 2 into 0. How do I turn 2 into 0? Okay, you're going to multiply a row by -2 and add to it. There's a 1 on both of them. Think about what would happen if you multiplied row 1 and added it down there. If I multiplied this times -2, I would get -2 plus 0, and that would change my 0. You always want to use the 1 right above it. Okay, so I want to do -2 times row 2 plus row 3 to turn that into a 0. The reason why I don't want to use row 1 at this point is it would mess up my 0 in my column 1. So I get 1, 1, 2, 19, 0, 1, 2, 13. Down here, 0 times -2 is 0, 0 plus 0 is 0. -2 times 1 is -2, -2 plus 2 is 0. -2 times 2 is -4, -4 plus 0 is -4. 13 times -2 is -26. -26 plus 6 is -20. So close to being done at this point. I got column 1's good, 1, 0, 0. Column 2 is good. It needed a 1 and a 0 at the bottom. Last thing on my diagonal, I have 1, 1. This one needs to turn into a 1. How am I going to turn that -4 into a 1? Yep, multiply it by -1/4 or divide by 4, however you want to think about it. And I get 1, 1, 2, 19, 0, 1, 2, 13. This time I'm dividing by -4. 0 divided by -4 is 0. 0 divided by -4 is 0. -4 divided by -4 is 1. -20 divided by -4 is 5. I have row echelon form. I have my diagonal 1s. I have my zeros underneath my diagonal. So I can put this back in with my x, y's, and z's now and solve it. The top equation says x plus y plus 2z equals 19. The second equation says y plus 2z equals 13. And the bottom equation says z equals 5. That's one of your answers, is z equals 5. How do I find the other two? Plug it in on the way up. So move up to the second equation. Y plus 2 times 5 equals 13. So y plus 10 equals 13. So y equals 3. Well, now that I know y and z, I can plug it in my top equation to get x. X plus 3 plus 2 times 5 equals 19. X plus 2 times 5 is 10. 10 plus 3 is 13. Equals 19. Subtract 13, and I get x equals 6. So my answer is x comma y, which is 3, comma z, which is 5. So 6, 3, 5. Questions about that? Okay, so you have 3 different ways to solve these not super fun 3x3 matrices. First way we learned is solving by hand. Get it down to 2 equations, 2 variables, then solve it, then back to substitute. That's the way I prefer to do it, personally. You also have Cramer's rule. That's what we learned on Monday. Today's Wednesday. That's what we learned on Monday. Cramer's rule is find the determinant of the, the different matrices and plug them all in and figure out the determinants, and then you get your answers that way. That way does not require much thought, but it requires much tedious writing. Okay. This is your third way. I feel like this is probably the least amount of writing. I wrote a lot here just because it was our first time to actually do it. I feel like this is the least amount of writing, but it's the most thought, personally. So it's kind of pick your poison at this point. You got 3 ways to do it. On your test, I'm going to give you one of them and I say pick a way to do it. I don't care how you do it. You just got to pick one way and do it. Okay. So get familiar with these different ways to do it. And you just need to be able to do one. But I will say you will, it's on your review. Let me go grab a review. Just a second. Let me grab a review real fast and I'll show you kind of what's expected of you. Okay, so on the front of this review, this is all log stuff. Okay, so the front is all log stuff, the back is all matrices stuff. So 2x2 systems, you got to be able to do substitution elimination. Okay, here's 2 word problems. Write the equations, solve it however you want to. Substitution elimination. You have to be able to find the determinant. You have a calculator that can do that. For 38, it takes longer to put in the calculator than it actually does to do it. But for 39, I think that one's, since it has zeros on top, it's still faster just to do by hand, but you can do the calculator. 40 and 41, it says solve these using Cramer's rule. So you have to be able to use Cramer's rule. Those are the short ones though, because they're the 2x2. This last one says solve using any method. So you can use Cramer's rule, you can use Gaussian elimination, or you can use substitution elimination. It's up to you for that one. Okay. So this is your review. This is 5 bonus points on your exam on Monday. We will go over this on Friday. I'm actually going to have an extra in-class review we're going to do on Friday, just like a practice kind of test, probably like 8 to 10 questions. We'll go over it together and then we'll spend the rest of the time going over this. So we're not going to have 50 minutes to cover this entire review. So I would encourage you to go home, look at it, and see what specific problems you want to make sure you go over. Okay. I'll see you on Friday.